Okay, everyone. So now we're going to cover section 35-4, the senses. Your EQ is how do humans sense changes in their environment. Okay, so make sure you do this. This is going to be um, on page, basically on the worksheet that you're filling out. That's worksheet number 6, Cornell notes on the senses, and that's going to be glued down on page 55. On the back side of the same worksheet, you have a chart that you can fill out either during this presentation or after the presentation. When you filled out the notes, you can go ahead and fill it in from the notes. Okay, so here we go. Okay, so first of all, how do senses help maintain homeostasis? So the senses gather information from the environment and send these signals to the brain for interpretation. Some examples that you can think of as we do this would be helpful to add here. And you have these are not going to pop up, so you can start thinking of some examples that you can think of that your body's doing right now to maintain homeostasis. What is homeostasis? Homeostasis, once again, is the stable internal environment. So, how is your body right now maintaining a stable internal environment? So, think about what you're doing, or maybe what you're wearing, or what's happening in order to maintain a homeostasis, and how the senses, your senses, are helping you maintain that. Okay, so sensory receptors are neurons that react directly to to stimuli from the environment. So something in the environment is happening, so the neurons react to it from what's happening on the outside of you. So, for example, light, the amount of light happening, the sound that's happening, the motion, chemicals, pressure, changes in temperature. These are stimuli that actually are sensed by your neurons in your sensory receptors that carry the impulses back to your brain. Okay, sensory receptors. There's 5 types that we have throughout our body. These are the 5. There's pain receptors, thermoreceptors, mechanoreceptors, chemoreceptors, and photoreceptors. And basically, they are all specific for the kind of stimuli that we constantly get from our environment. So we sense pain in order to protect ourselves. Thermo, think about thermometer, that's for temperature. Machines for from pressure and things like that. Chemoreceptors, chemicals in the environment, and photoreceptors, like photons, what makes up light. So photoreceptors are for light reception. Okay, so we're going to go through each individually really quick. I'm sure you're pretty familiar with the pain receptors if you've ever felt any pain. They're located throughout the body except the brain, which is kind of dangerous because when your brain gets hurt, you don't feel it. That's why it's so hard to know how bad concussions are and things like that, because that's basically bad parts in the brain. And it's pretty sad when people get concussions. They see if you get scanned, your brain scan, an MRI or something like that, they actually see like bruising that is permanent in your brain. Many times, people that have gotten a lot of concussions have like black spots in their brain where they actually have a loss of brain matter, and that's pretty scary. So, and you don't feel it because there's no pain receptors there, and that's why you just feel dizzy or something. That just means that your brain is injured, but unfortunately, there's no pain there, and pain receptors, so you don't feel that it's actually hurt. You just kind of feel dizzy or whatever. Okay, so and what these do is that the pain receptors respond to chemicals released by damaged cells. So that means that there's damage to the cells. So usually indicate danger or injury or disease. So these are really, really, really good things because when you're injured and you have a cut or you have a bruise, you try to keep off of it. You don't touch it, and that prevents further damage to your body. So it's actually a good thing to feel pain. A few years ago, there was someone on Oprah, a little girl that was born with inactive pain receptors. She had a weird mutation. She was born without the ability to feel pain. And as a little kid, she poked out one of her eyes. She did all kinds of damage. She broke, she didn't have any fingers because she actually got them so hurt that they had to amputate them. She was missing, like I said, an eye, one ear because she poked it so much that she got an infection. And she was only like 2 years old. So she was like, she did, when she fell down, she never felt the pain. So she kept on falling down. And when she would poke at herself, herself. She didn't know, she didn't feel it, so she just kept on doing it until she poked her eye out. So these are pain is actually so, pain receptors are actually very useful in helping us understand how to protect ourselves from further damage. Thermoreceptors. Thermoreceptors are located in the skin, body, and hypothalamus. That's part of your brain. They detect various variations in body temperature. So these are the ones that tell you, like many of you guys, like if the air conditioning's on really high in the classroom, it will tell me, oh, it's cold, or turn on the air, oh, it's hot. That's because of your thermoreceptors. So the next ones are chemoreceptors. Chemoreceptors are located in the skin and skeletal muscle and in the inner ear, so they're inside your ear. And they basically are sensitive to touch, pressure, stretching of muscles, sound, and motion. So basically, these are the ones that move. These sensors sense movement, touch. Stretching of muscles. So that's how you know that your arm is where it is. If you stretch it out, even if you close your eyes and can't see your arm, you can feel your muscles stretching. It's also it helps you locate your feet, even though they're underneath the table. You kind of know where your feet are. This is because of the mechanoreceptors in your skin, your skeletal muscles, and inside your ear. That's how you can hear sound. So these are called mechanoreceptors. Many of us think like the ear. Well, you have little hairs in your ear that basically move around when there's sound, and the more they move around, the louder it sounds to you, and that's why they're involved with movement, so that's why they're called mechanoreceptors. Number four is chemoreceptors or chemoreceptors. They're located in the nose and taste buds. They're sensitive to chemicals in the external environment. So you have your tongue that allows you to taste bitter, sour, salty, and sweet. And then you have chemoreceptors in your nose that also allow you to smell things from the environment, chemicals in the environment. And they can really help you better get a gauge for what is good, what's bad, and what you should just spit out because it's bad, or a smell that tells you something is rotten is very useful in avoiding rotten things and poison. So these are very good for keeping you away from bad things as well as attracting you to things that are good. So like bread baking or cake baking, something like that. That smells really good to us, or French fries. That just smells really good to us because they're high in calories, and that's supposed to keep you healthy if you're starving. Photoreceptors located in the eyes. They're sensitive to light and color. So these are photoreceptors. Pretty straightforward. That this is how we see light and color. Okay, so now we're going to go to the five types of senses that we find in our body. So that's what you do in the fill-in. Five types of senses. So we're going to go through them individually. Okay, so your eyeball, your eyes, your vision. The first sense is vision. The eye, it has a pupil, which is you see there in the diagram. The lens, which is right on the bottom there, you can see the lens. The retina, it's behind the lens where light is focused into images. It holds two types of photoreceptors, which are rods for light and cones for color. And so if you inherited good rods, you can see light, which is good. And if your cones are not mutated in any way because you got the wrong information, you can see all the colors. So that allows you to see colors. And those are the photoreceptors that are embedded in the eye. And there's blood vessels in the back. On the retina, there's all kinds of blood going there to make sure that everything is fed. So there's a lot of blood going to your eyes that we don't see. But in the next picture, you'll actually see, sometimes in pictures, when you take a picture of actual eyes, you can actually see if the pupil is open, you can actually see the back of the eye. So here you've got red eye. You sometimes see red eyes in photographs where a flash was used. And that basically what happens is that if it's dark and your pupil's dilated and you could see, basically you're taking a picture of the back of the eye. That's why you get red eyes, because the light flashed and your pupil wasn't close, it didn't dilate and close it fast enough. It was really fast, so it didn't have time to close all the way. So your pupils were dilated and boom, you get the red eyes. So, and the red eyes are basically because of you're taking a picture of the back of the eye. It's kind of creepy. The second sense is a smell. What organs sense smell? Well, it's our nose. It senses chemicals with chemoreceptors. Uh, yes, smells are in fact just chemicals in the air. Much of what you taste comes from scent. So actually, most of what we think is, oh, we're tasting that. No, it's actually the chemical receptors, the chemoreceptors that we find in our nose that's actually giving us the taste of the food. That's why when you're sick and your nose is all plugged up, you try to eat and it doesn't taste the same. It has a different taste. That's because your chemoreceptors are all covered up with mucus and they can't work right now. And so you're eating and it doesn't have much of a taste because your tongue isn't actually tasting it. It's your smell that makes the food good. So taste, what organ says this? Taste? Well, that would be the tongue. Taste buds, salty, sweet, bitter, sour. So those are the taste buds that you have. They're also things stimulate the chemoreceptors, and yeah, taste does in fact come from chemicals too. Hearing is the next sense. Use your ear for hearing. It's sensitive to vibrations in the air. There's tiny hairs moved by sound. So sound waves move those hairs, and the movement stimulates chemoreceptors in your ear. There's also liquid inside your ear that helps you with balance. So it helps you keep, even if you close your eyes, you kind of know that you're moving sideways or swaying. That's because of the water that moves the hairs inside of parts of your eye that help keep your balance. It's an inner ear part, the cochlea. Okay, the next sense is touch. Skin, your largest organ. Your skin is actually an organ. It's the largest one you have throughout your body. It has pain receptors, mechanoreceptors, and thermoreceptors throughout the skin. It basically puts all of those receptors all over your body, and it responds to touch, temperature, and pain. We're very familiar with our skin. The sense of touch. Not all parts of your body are equally receptive. Concentration of sensory receptors determine how sensitive an area is. Which body parts do you think have the highest concentration of sensory receptors? So think about it. Which ones are more sensitive to touch? Is your back the most sensitive to touch, or maybe your fingertips, or maybe parts of your body? Like, is your face as sensitive as your feet, or are your feet more sensitive than your face? Where can you sense things better? And just to review, these are your five senses. There's vision, taste and smell, hearing, and touch. Okay, and those are we've got for vision, you've got photoreceptors in the eye. For taste and smell, you've got chemoreceptors in the nose and tongue. Hearing, you have mechanoreceptors in your ear, and touch, you have pain receptors, mechanoreceptors, and thermoreceptors in your skin. Okay, so these are the five senses, and you have the different receptors that you have all over them, inside of them that help them do their job.